Okay, so you understand the concept of how to balance equations and you are getting the hang of it, but you might have a hard time thinking, where the heck do I start? What is the strategy for the balancing equations? So I have three strategies and I'm going to go through them one by one. The first one is for all of these, I look at the whole equation to get an idea of what type of reaction am I looking at, because not all strategies are going to work each time. So in this case, I look and I see that I have oxygen in one, two, three different locations. Hydrogen is only in two locations, and carbon is also in two locations. I want to avoid, I'm absolutely going to avoid, so avoid the atom in the most locations. So I'm going to do oxygen last. I'm going to do oxygen last. Okay, so O last. Carbons, hydrogens, and oxygens, that's what I'm going to be balancing. So on the reactant side, I can pick carbon or hydrogen because they're both in one. So I'm just going to start with carbon. I have two carbons in the reactant side, only one in the product, four H's on the reactant side, two in the products, and oxygens, I have two in the reactant side, and I have two, three in the product side. Okay, so I said I was going to start with carbons first. So I see I have two on the left, only one on the right. So I need to bring in another CO2. When I bring in another CO2, so bring in two of those, that will give me two carbons. Now notice when I brought in that second CO2, I also changed the oxygens. So I'm not going to do anything with that, but I know anytime I bring it in, I know, ooh, I changed the number of oxygens also. Okay, now hydrogens on the left, you have two, you have four, and on the right, you only have two. So you need two more hydrogens. So you're going to bring in another H2O. So I bring in another H2O, my second H2O, that gives me four H's. Now I have two O's on the left, and I have, let's see how many we have on the right. We have two CO2s, that gives me four, plus another two H2Os, that gives me two. Four plus two is six. Now I have six oxygens on the right. I need six oxygens on the left. So if I have three O2s, O2, 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 three times two is going to give me six. Okay, now that I have it all done, I'm just going to double check it one more time. You can visualize it however you need to. So I have two carbons on the left. I have two times CO2. I did do two times one. So I know I have two. Yes, okay, good. Hydrogens, I have four. On this side, I have two times two is four, yes. And oxygens, I have three times two is six. Two times two is four, plus two times two is six. Yes, so it is a balanced equation. You don't have to check your work that way, but that's just the way my brain thinks. Okay, so my next strategy is looking for polyatomic ions in the reactant and the product, because if they're in both locations, yay, I'm going to keep them together. I'm not going to divvy up the nitrogens and the oxygens. I'm just going to consider it as a unit. So I have, and now this time, instead of just writing each atom type out, I'm actually going to put, I have K, NO, I, NO3, and PB. PB is lead. Okay, so we have one potassium on the left, one potassium on the right. I have one iodide on the left, and I have two on the right. I have two nitrates on the left and one nitrate on the right. And I have one lead and one lead. So right now, lead is balanced and potassium is balanced, but the other two are not. You can start with either one because notice they're all in the same number of locations. So let's start with, I love to start with my polyatomic ions when they're just in both locations like this. I have two over here and only one over here. So I'm going to bring in, I need another NO3, but I can't bring in NO3 by itself. So I'm bringing in another KNO3. And that changed not only the number of NO3s, I now have 2, but I also have 2 potassiums now, 2 Ks. Now I go to the left side, I need 2 potassiums, so I have to bring in another Ki. And when I bring in that other Ki, I now have 2 potassiums, yay. And I also have 2 Is now. And now my equation is balanced. I have 2 potassium iodides, so 2 Ks, 2 Is, 2 Ks, 2 Is. I have 1 lead, 2 nitrates, 2 nitrates, and my equation is balanced. Okay, so the last thing I look for is a 2-3 situation. We don't have these very often, but what I mean by this 2-3 situation, remember when you had, say you had aluminum plus 3, oxide minus 2, and you had to get to the plus 6, you had to use a combination of these two. So this happens when you have the atom in just one different location on both sides, and you have a 2 and a 3, or a 3 and a 2, because the only way for me to get to 6 is to do 3, 3, or 2, 2, 2. Okay, so you might see this example and it might feel a little guess and checky, but when you recognize you need 6, it's gonna be much easier to do. Okay, so I have aluminum, oxygens, and that's it. In the reactant side, I have 1 aluminum and 2 oxygens. And on the right side, I have 2 aluminums and 3 oxygen atoms. Okay. Now, we already said that it's 3-2 situation. So when we look at oxygen, can you see that it's only in one location on the left side and only on one location on the right side? So I'm going to need to get this to 6. I'm going to need to get this to 6. So I'll put a little 3 in front. I wish I had left a little more space on that. I'm going to put a 3 in front of the O2. And a 2 in front of the, oops, geez, I need more space. A 2 in front of 2, Al2O3. So that looks like this, right? You can see that that's going to give you 6 oxygens on the left and 6 oxygens on the right. So I have still 1 aluminum on the left. Now I have 4 on the right because I have 2 of these. And on the left, I have 6 oxygens. 3 times 2, 6 oxygens. Picturing O2, O2, O2 3 times. And on the right, I have 6 oxygens. Okay, so we're almost done. All we need to do is balance the aluminum. I have 1 on the left, 4 on the right. So I need to put a 4 in front, and that will give me my balanced equation. Okay, so these are my 3 basic strategies. Honestly, I usually look for the first one. This is like the most used one for me, is looking for it in the least number of locations and avoid that guy. I don't want to have the one with the most atoms. Second one, if I have a polyatomic ion and I can see it's together on both sides, I keep it grouped. And third one is the 3-2 situation.